In the realm of end-to-end automatic speech recognition, E2E, recent advancements in deep learning have propelled systems to new heights, making them the backbone of many speech recognition applications. However, data coverage greatly impacts these techniques, leading to performance degradation for sentences containing rare words. To address this issue, researchers have proposed two types of methods that integrate context information into E2E systems. The first method involves compiling biasing phrases into a finite-state transducer and incorporating it into the decoding process, which requires calibration to find the optimal fusion weight. The second method uses encoders to directly inject context information, such as CLAS and CATT, which leverage contextual information through an additional location-aware attention mechanism. These models enable personalized entity lists for individual users but may result in false alarms, negatively impacting overall recognition performance, especially for phonemically similar words. To mitigate this issue, we propose an adaptive contextual biasing method based on the Context-Aware Transformer Transducer (CATT) model. Our approach utilizes biased encoder and predictor embeddings to perform streaming prediction of contextual phrase occurrences. This prediction is then used to dynamically switch the bias list on and off, enabling the model to adapt to both personalized and common scenarios. Our approach introduces an entity detector module to predict the occurrence of context words, assisting in determining when to use the context list during inference. This module is designed to differentiate acoustically similar words and minimize false alarms. The proposed framework includes a context encoder that converts a list of context words into context embeddings, which are then fed into the encoder and predictor biasing layers. These layers allow the model to learn the relationship between contextual phrases and speech through a multi-head attention (MHA) layer. The audio embedding serves as the query vector, while the contextual phrase embedding refers to the keys and values vectors. A combined module consisting of a layer norm layer, concatenation operation, and feed-forward projection layer processes these outputs. To predict the occurrence of context words, we add a predictor-based entity detector (PED) that uses the predictor output as the query vector and the contextual phrase embedding as the key and value. The entity detection embedding is calculated via multi-head attention, and this embedding is used to perform a two-class classification task against the ground truth label of the text via a linear layer. A cross-entropy loss, Librispeech, is calculated, and the final joint loss function for our model combines the transducer loss and bias loss with a weight hyperparameter lambda1 set to 0.4 in all experiments. Experiments on Librispeech and an internal voice assistant dataset show that our approach can achieve up to 6.7% and 20.7% relative reduction in word error rate, WER, and character error rate, CER, compared to the baseline, mitigating up to 96.7% and 84.9% of the relative WER and CER increase for common cases. Our approach has a minimal performance impact in personalized scenarios while maintaining a streaming inference pipeline with negligible real-time factor (RTF) increase. The research paper discusses a novel approach to reduce the word error rate (WER) increase in common scenarios introduced by biasing modules. The authors propose an adaptive method based on an entity detector that predicts context phrases in utterances and calculates cross-entropy loss on these predictions to train the entity detector to filter out irrelevant entity lists during inference. The approach is evaluated on the Librispeech benchmark and an in-house voice assistant dataset. Results show significant WER reduction for common scenarios, with up to 6.7% relative WER reduction for the test other set with an entity list of 20. The entity detector's low false alarm rate and ability to predict context phrases with a low LCER under 5% contribute to this improvement. An ablation study further validates the effectiveness of the proposed method, showing improvements over baseline and 50% bias conditions. The addition of the proposed module leads to a minor increase in runtime, but the computational cost is negligible. Overall, the approach demonstrates better performance in common scenarios, making it a significant advancement in speech recognition technology. In the realm of speech recognition, end-to-end contextual models have emerged as a promising approach. These models leverage the capabilities of neural networks to transcribe speech directly from audio signals without the need for handcrafted pronunciation dictionaries or language models. A key component in these models is the connectionist temporal classification (CTC) loss function, which allows for unsegmented sequence data to be labeled using recurrent neural networks. This paper builds upon previous work in contextual speech recognition by introducing a novel contextualized word biasing technique that enhances the performance of streaming and non-streaming transducer models. The proposed method utilizes a two-stage process. First, it applies a contextualized word biasing mechanism to adjust the probabilities of words given their context, and then it integrates this biasing into both streaming and non-streaming transducer models. This approach is demonstrated to significantly improve the performance of these models on various datasets, including Librispeech and GigaSpeech. Furthermore, the paper explores the use of a new alternate spelling prediction model to enhance the recognition of rare words in speech. The authors also delve into the importance of contextual information in speech recognition, highlighting how incorporating contextual cues can greatly enhance the accuracy of transcriptions. They discuss several techniques for integrating contextual information, such as using class language models, word mapping, and shallow fusion end-to-end contextual biasing. Additionally, the paper provides an overview of various data augmentation methods, including SpecAugment, which is a simple data augmentation method that has been shown to improve the robustness of speech recognition systems. Moreover, the paper touches on the topic of collaborative decoding, which involves combining the outputs of multiple models to produce a single transcription. This technique has been found to be particularly effective in enhancing the performance of end-to-end speech recognition systems. The authors also discuss the role of beam search in contextual speech recognition, emphasizing its ability to efficiently explore the space of possible transcriptions and select the most probable one. Finally, the paper concludes by highlighting the importance of further research in contextual speech recognition, particularly in terms of developing more efficient and effective models that can handle complex linguistic phenomena. It emphasizes the need for continued advancements in contextualized word biasing, collaborative decoding, and data augmentation techniques to push the boundaries of speech recognition technology.